for state 2, but I'm not going to even bother because as I said, I've constructed state 2 to be symmetric with state 1. So just as I argued that in state 1, Alice would go top, Bob would go left, by a very similar argument, we'll expect that in state 2, Alice will play the bottom strategy, Bob will play the right strategy, and we'll get gas, which is optimal in state 2. So in both states, we get the right outcome, even though the mechanism designer didn't know the state, and even though Alice and Bob weren't interested in getting a compromise, the mechanism designer wanted to get a compromise, Alice and Bob just want to get the energy source that's good for them individually. And we say that this mechanism implements the designer's goals. The goal is to get oil in state 1, gas in state 2. Okay, so I've given you these 3 examples, the cake, the telecom, and the energy examples. You might complain that all of this seems a little bit too contrived, a little bit too ad hoc. You might ask, and I certainly would agree with you, whether it would be possible to get a more general analysis. So what kinds of general questions might we ask? We might ask, is there a general way of determining whether or not a goal is implementable? In the 3 examples I showed you, it turned out that the designer's goal was implementable. But in fact, there are plenty of cases, sadly, where there's no mechanism that can be found which would implement a designer's goals. But if the goal is implementable, we might ask, is there a procedure we can follow, an algorithm perhaps that we can use, which would identify a mechanism that implements the goal? Well, it turns out that the answer is yes to both questions. Don't worry, I'm not going to go through the analysis today, but if you are interested, I'd refer you to this old paper of mine, which attempts to show why the answer is yes to both questions. And there's been a lot of work since then which generalizes and extends and refines the answer. What I do want to say, though, in conclusion today, is that although mechanism design now has been around for many years, in fact, the creator of mechanism design, Leo Hurwicz, Alejandro mentioned Leo Hurwicz in his introduction, the first papers that Leo Hurwicz wrote on mechanism design came out almost 50 years ago. Leo Hurwicz's first paper on the subject was published in 1960. So the subject has been around for a long time, but there's a sense in which some of its most important applications are still out there, waiting for you to solve. And let me mention 2 of them. And here they are. I'll take them one by one. We're all aware that the Earth is heating up, that the Earth's atmosphere is heating up, and we also know the reason why. It's because we're putting greenhouse gases, in particular carbon dioxide, into the atmosphere. And we also know that if we continue to allow this to happen unchecked, that it could lead to catastrophic results, not tomorrow, but maybe 40, 50 years from now. So there's an obvious social goal that we want to, that most of us want to achieve, and that is to reduce the emissions of carbon dioxide into the atmosphere. The problem is that that social goal is in conflict with the individual goals of the countries around the world. Each country would like all the other countries to reduce their carbon emissions, but it would prefer not to do so itself because reducing carbon is expensive. It has an economic cost. It means adopting new technologies, or it means reducing output, or it means shutting down factories. All of this is expensive, and therefore there's a conflict, just as in the 3 examples I already showed you, between social goals and private incentives. How do we reconcile that conflict? We do so through an international treaty. A properly designed international treaty will induce each country to sign that treaty, even though it has its own agenda. A properly designed international treaty will give each country enough to gain from having the treaty go through that it will be willing to compromise a bit in order to see the treaty succeed. Well, a treaty is just a mechanism. It's exactly a mechanism in our mechanism design language, and designing a workable international treaty is an exercise in mechanism design theory. Now, I don't have the solution to show you today, but the next time I come here, I expect one of you to show me the solution, because this is an important, outstanding problem. Another important, outstanding problem is stopping financial crises. Now, how do we do that? Well, we're still in the midst of the current financial crisis. This crisis was caused by a failure of government regulation. It was caused because there was a conflict between the private goals of banks, which was to make as much money as possible, and the social goal that we all share of having a stable and workable financial system. As we saw very clearly, those two goals are in conflict, and the way that we reconcile those two goals is through a mechanism of regulation, that is putting limits on what banks and other financial institutions can do. Now, exactly what that financial mechanism should look like, again, I don't have the answer to today, but I imagine that many of you might be participating in that answer in the years to come. But for now, I'd simply like to thank you for your attention. It was a pleasure having the chance to tell you about mechanism design theory. Many thanks.